Hello and welcome to this SPAX Performance Suspension Training Guide. We'll provide you with a basic introduction to the components and operation of a car suspension, and as SPAX manufacture shock absorbers, we'll focus on the role of dampers. A car suspension system comprises tyres, springs, associated linkages and the shock absorbers or dampers. The primary task of suspension is to keep the wheels in contact with the constantly changing road surface, and it will need to be tuned to ensure a compromise between road holding, handling and passenger comfort. Without adequate suspension, it wouldn't be possible to drive a car. The components in a suspension design provide a stable platform to transport passengers in comfort and safety. Three main attributes afforded to the driver by a car suspension are comfort, contact and control. When a car hits a bump in the road, it's desirable that the occupants and load are disturbed the minimum amount. If the vehicle hits a pothole, drives round a corner or brakes sharply, then the aim of suspension is to absorb impact and transport the driver and passengers so that they are insulated to the best degree from external forces. Ideally, a car designer would like to ensure that all four tyres will be touching the ground constantly. This will provide grip, stability and control. Remember, a wheel in the air doesn't generate any grip at all. To control a car, the ability to maintain, as far as possible, the mass of the vehicle in a stable position and to ensure it can accelerate, stop and turn precisely and safely is required. The primary components of any car suspension system are the air and rubber in the tyres, having an inherent stiffness and damping. Sadly, the fashion for larger, heavier wheels with less and less rubber on run-flat and wider tyres has done nothing to help ride quality, although larger rolling diameters do help. The secondary components are the springs, dampers, suspension arms, axles, bushes, drop links, torsion bars, anti-roll bars, and etc. With the third level of suspension being the interface between the car and the driver and passengers, more commonly known as a seat. Springs are simple and essential devices. They're designed to support the mass of the vehicle, including the engine, body, chassis, gearbox, interior, passengers and goods. The weight carried is known as the sprung weight. Designers strive to minimise the unsprung weight of a car. That's the wheels, tyres, axles and lower suspension components. This is done so that the suspension system overall can minimise the necessity to compensate for those parts and give the majority of their attention to the sprung mass. Springs are energy storage units, whether coil springs on modern cars or leaf springs on older or commercial vehicles. All a spring can do is store and release energy. When suspension springs are compressed, they store motion energy from the force pushing in, and when the external force is released, the stored energy expands the spring. Springs aid passenger comfort as they cushion the external forces encountered as the car is driven, but if a car only had springs, it would constantly cycle the stored and released energy and the vehicle would continuously and dangerously bounce. To act in unison with a spring, a damper, or shock absorber as they're commonly referred, is required to mitigate the natural inclination of springs to oscillate in use. In simple terms, a shock absorber will provide resistance to the movement of the spring by absorbing energy being used to compress and expand. This energy will be turned into heat. Some suspension systems employ struts. These are a combination of a spring and damper, and they're used as a structural component of the vehicle. Struts, just like dampers, will help dissipate the movement energy produced as the vehicle travels, helping keep control of the car. They also serve to eliminate the need for other suspension components, for example upper control arms, and this minimises the unsprung weight and keeps down expense. So we've seen that dampers, or shock absorbers as they are called, are necessarily employed to dissipate the energy and smooth out cyclical response in a spring, literally damping energy to smooth the ride. A damper is effectively a piston in a cylinder surrounded by oil. As the vehicle hits a bump, the piston is compressed and some of that oil will be forced through holes in the valve block. The rate of oil transfer is regulated through a valve assembly. As the oil is circulated through damper, whether in bump, that's compression stroke, or rebound, extension stroke, motion energy is absorbed and heat is released. Kinetic energy creates the heat and dissipates the movement forces created. Dampers are hydraulic in operation and will react to the velocity that hits them. If a car is being driven quickly and hits a bump, or slower, hitting a larger bump, then the damper shaft is driven at high speed, producing increased damping. If the shaft speed is lower, as the car is driven at slower speeds for example, less damping will be produced. Dampers are not just employed when a car hits a bump in the road. If the car is turned, brakes or accelerates, then all these actions will create consequential spring action, all to be damped. As a car turns, springs will be compressed. On the other side, the springs will be extended. If the car springs are left to their own devices, then the constant transfer of energy will induce body roll, adversely affecting road holding, car control and driver comfort. Similarly, as a car brakes or accelerates, the front and back springs will be in motion. In a typical journey, constantly combining speeding up, slowing down, turning and hitting bumps and potholes in the road, dampers will be constantly working to offset the competing forces of momentum and help the driver keep good control of the vehicle. The majority of dampers on cars are fixed rate. The damping forces have been calculated by the manufacturer and comprise a design for that particular vehicle which will serve to provide adequate damping for the majority of driving styles and road conditions that those particular cars will encounter. Also, in common with the majority of original equipment fitted shock absorbers, the harder those dampers are worked, that's the faster the car is driven or if the road surface becomes poorer, then the effective performance of the damping deteriorates. This is called fade and occurs when air is cavitated, that's bubbles forming the oil, in the damper chamber. Dampers are mechanical devices which are constantly employed during every journey, and over time their performance will degrade and eventually they will require replacement. Drivers often look to improve the performance of their vehicles, and a quick, easy and relatively inexpensive way to improve the safety and performance of any car is to fit upgraded dampers.